I will be moderating this afternoon session. So we spent the morning hearing from lots of great experts, learning what ponds are, how they came to be, how are they functioning, in some cases how are they not functioning, and we're going to keep building on this story and kind of get into, okay, well, now reality sets in. Our engineers have designed these ponds, we've built them, we have thousands of them across our landscape, so now what? We really got to understand that basic science and that regulatory and historical context to get into, how and why are we inspecting and monitoring and diagnosing these ponds. So with that, we've got an exciting session for you. We have 2 speakers I will welcome up shortly, and then we're going to break into small group discussions, have a short break, and then get together for an interactive panel. So with that, please welcome up John Chapman.
Thank you. Thank you all for being here and for having me speak. This is great. So I was asked to speak and to touch on a bit of the inspection regulations here right after lunch. I don't know if that was the best plan, but hopefully nobody falls asleep. And then I'll talk a little bit about the start of kind of assessments and some of that, and then I'll hand off to Purnima in a bit to carry on and drill deeper into ways to do assessments. I am going to start off talking about the NPDES construction stormwater permit. I know Todd and Ross already talked about this morning. There's all these pieces of it that are required in that permit, but then the one piece that hasn't been mentioned much so far is this last one on my bullet list. It's identifying the long-term maintenance provider. That is a requirement in the construction stormwater permit. And the other piece is at the end of construction, all of these systems need to be cleaned out and basically turned over to that long-term owner in a clean, operable state. So those are 2 key requirements to think about as far as ponds go. I'm going to run through a little bit about MS4 permits as well here in regards to the inspections and monitoring. Of course, in a MS4 permit, we need to have a stormwater pollution prevention program. I'm always annoyed that it's the same acronym as a construction stormwater pollution prevention plan, but that's the Clean Water Act for us, I guess. But in that program, we have a goal of reducing and preventing pollution. That is part of that MS4 regulation or guide, as Todd put it this morning. Within that, the good housekeeping section, again, requires maintenance, or it requires inspections and maintenance, employee training, and documentation. So those are all in that MS4 permit. Drilling into those in a little bit more detail, inspections. The language is that we're inspecting all of our ponds and outfalls at least once per permit cycle. So that's once every 5 years, assuming that it renews on time. And there's also an annual assessment of our maintenance program. And that includes the structural stormwater BMPs being annually looked at. So it's not just looking at every pond every 5 years, but you think about it, it's really more of an annual checking up on the whole system. And there is some language that if you have 2 years of inspection data, you can back off and do a inspection every 2 years. So that language is in there. And then we're doing this really to make sure that everything is functioning properly. And they have some specific language about that proper function. I won't read through that in detail, but that's just kind of wrapping up the MS4 components of this that are requiring us to do our inspections on ponds and look at the maintenance activities on ponds. We also have a little bit of employee training mentioned in there, that the employees need to be, who are doing this maintenance, need to have their whatever their job duties are, they need some annual training on that, or a reoccurring training, I guess is the actual language, but that's often seen as an annual training. And then the documentation, which I think is so critical. I think that came up earlier when our speakers were talking about the monitoring and maintenance and having data, and how if we had the data, we could do so much more, or we could, have such better designs. And I feel like it's kind of baked into the system a little bit. If when we do our maintenance and we record that information, and that's documented, that's our data, right? We should mine back into that. And there should be this continuous loop of the designers going back to the projects that they worked on and looking at the data of how they're being maintained, what's working, what's not working. That is it's a critical step that I feel like we could do a better job with. So that documentation is super important. The last bit of regulations that I'm going to touch on is dredging. And I know tomorrow there's a whole section on dredging, so all I'm going to point out is that there was a flurry of guidance that came out about 12 years ago from the MPCA, some fact sheets. There were 2 guidebooks that came out, and all of this, there was actually, even in those guidebooks, it even has a threat, I'll call it a threat, of requiring a SDS permit if you're going to do excavations and you're going to have that sediment. That was listed in there, and this is a flow chart of how you determine if you're going to have to apply for one of these SDS permits. And I don't believe there's ever been an SDS permit issued for a pond maintenance activity or handling those sediments, but it's potentially in there. And a lot of these guidebooks were about kind of this monitoring or understanding what you have when you're going to go out and do maintenance, taking cores, taking samples. And of course, this was really keyed into the PAHs. That was the pollutant du jour. And so that was really focused on that and making sure that if you're going to handle these sediments, that you had a good understanding of what was in them and if it was carcinogenic or not. In the end of all of that, I feel like regardless of what procedures you would follow, a lot of that was guidance. But in the end, owners are responsible for the sediments, and it's regardless of the procedures of monitoring and handling and everything else. So you kind of own them. If this is your pond, you own the sediments, dispose of it as you think is fit, but you own them. And if you do something wrong, you're still liable for that. And so that kind of wraps up my regulation. It doesn't look like anybody fell asleep, so that's awesome. Great. Thank you for bearing with me on that. I'm going to jump into a little bit more about the pond assessments now. And I'm going to lead off talking about having a plan. I guess I'm up here on my soapbox. I think it's so important, if you're going to do an assessment, to start by having a plan in hand, that you know what you're supposed to be assessing, right? You understand how it was built, you understand what should be there, so that when you're doing your assessment, you're looking for the right stuff. And so having a written management plan or a manual, whatever you want to call it, inspection manual, and the ones that I've worked with, I really feel have these 4 components that they assign responsibility. They have guides for how you're supposed to do the assessment. They have procedures to restore the function of how this was, meant to be working. And then there's that record keeping again, as I said before. That's so critical to document what's successful, how quickly is that sediment building up in the system. So there's examples out there. This is one from Cottage Grove. This is a really neat one from New York State. Just different ways you can create these plans. But in the end, I think having the first step of assigning the responsibility. And as I went back to that first regulation with the construction stormwater permit, requiring at the time of construction, we're supposed to say who is that long-term maintenance provider, right? That before this thing is even built, the owner is identified and the owner knows what they're getting into. It's such a critical step. And so having that plan, again, lock into who's responsible for this. And this, what we see here is a document. You probably can't read it, but it's It actually comes from the Coon Creek Watershed District, and it's an agreement that they have to assign maintenance responsibility to the owner if they're putting in building a stormwater treatment system of some sort, a rain garden, whatever it is. And so it locks that responsibility in. That owner knows what they have to do, and I believe that gets deeded into the property then. So with that, once we have our plan and we've assigned responsibility, we're going to do our assessment. And I'm going to chat a little bit about visual assessments. And the next speaker after me is going to drill down into some other options. But I'm just going to focus on the visual assessments right now. And this was really well established back in about 2007 with Andy Erickson, Pete Weiss, and John Gulliver, and the other people working with that team to really establish some really nice inspection forms. And again, this kind of goes back to what I was saying about having a plan, right? This is the start of an inspection plan. It gives us a checklist. There's information there that we're going to record. We're going to be consistent. We're going to have this written documentation of what we looked at. And there's a whole bunch of these forms available. You can use this QR code to get to them all at the SAFL website. And these will start then by putting in a sketch of some sort, kind of drawing where your site is and what's there. If you have the existing plan set, that is even better to be able to understand what was originally built. How deep is this supposed to be? All these things are so critical to that visual assessment. Once we get out there and we have that plan in hand, we can start to think about what is the vegetation around the site. This is an example. This is actually that same image here. We have a triangular pond. Going back to the 3-to-1 ratio and some of these things that we heard earlier, I think you'll probably see some of those patterns in this pond system. But if you get out here and you didn't know that, would you exactly understand what's going on? That first cell is fairly well sedimented in. There's a lot of vegetation growth around this. And so that's part of your visual assessment. You can do a lot visually if you know what to look for. And I think the visual assessment is so attractive because it's affordable and it can be very effective to just document what's going on. The staff training is not that extensive to try to get people up to speed on knowing what to look for. So understanding that what vegetation is there, what's supposed to be there, what might be invasive, if there's trees in the area that shouldn't be there, kind of going back to that earlier discussion. Are trees going to compromise the design or make it successful? Were trees intentionally planted as a visual screening or not? Understanding that in a plan will help that inspector know what's maybe a problem and what should be removed or what should be left in place. You're going to look at the inlet for these systems, right, where the water comes into the pond, inspecting that for its structural integrity, that the concrete isn't failing, there isn't a tree or something growing right next to it that might crack the concrete. Trash guards are another aspect that would need to be inspected and make sure they're not clogged. There might be some riprap and erosion control features around that inlet that need to be looked at and make sure that those are in good shape. You might see water quality problems, right? If you see something like this, you see a sheen, you initially might think we've got an oil spill. There's some sort of petroleum discharge and concern. On closer looking, closer inspection of this actual thing, that is not a petroleum-based sheen. That is something that's occurring from just the natural degradation of the vegetation. If you poke it with a stick, it basically cracks. It doesn't. An oil it wouldn't crack. It kind of adheres to the stick, and so from the behavior of it, you can visually see that there's not been an oil spill here. So I think that's again something that you can do visually if somebody's trained and they have the right plan that explains, this is this is what you might see, and this is not a problem, but if you see something else, this would be a problem. And more often than not, at this pond, I see this condition happening. So it is common, and it'd be easy to document in a plan. And then the outlet structure is the other key area that you might look at visually to make sure that that's functioning right. If you're doing an annual inspection, you might also exercise any valves or anything like that that you'd have on site. But typically, just an observation. Is it clogged? Is it functioning? Just from a visual inspection is often enough. And so that leads us with a large part of that maintenance plan that visual inspection can understand if this thing is working or not. The maintenance plan would go on and discuss a restoration of function. In a pond situation, a lot of times we're going to have to do some excavation. And I'm going to take a little bit of a tangent here and talk about design method for maintenance. When we think about doing a design, and I know we've all thought about this, but being able to optimize our design so that it's most cost effective. And what I'm going to mention is the idea of thinking about maintenance in that cost evaluation. So we'd calculate the effectiveness of all of our pre-treatment options and the cost of the total excavation of the system and balance all those. And we're actually in the middle of a study into that. We're looking at 71 different ponds here from Minnesota and Canada. And in our initial numbers, it's kind of interesting. So we've looked at if you sized a pond forebay, is there an optimal cost, kind of the minimal cost for different sizes of forebays? And based on just this one example pond that we've looked at, if we have different forebays from a 0% up to roughly an 18% of the total pond area, and we do an economic evaluation of the typical cleanouts that you'd need, it might be a cleanout every year, or every maybe almost 1.5 cleanouts a year, almost 3 cleanouts a year, depending on the size of that. You have a different cost over time. And if you plot all that out, you can actually see there is a low point in the cost. We have an optimal cost for this kind of a system if the forebay is sized at about maybe a 7% of the total pond area. And I think that's really interesting, and the study isn't done. We're looking at other aspects of pretreatment with sumps and other features as well. But the idea of every forebay should be 15% of the pond area, I think we might be able to do a little bit better than that number and put a little bit more behind that. So that in your plan, to have a design which is optimized, and maybe if we design for a 5% forebay and it says we should be cleaning that out 2.5, 3 times a year, this is where our maintenance activity and the record keeping is really going to help us understand if we're successful or not. To have those maintenance crews out there, and if that's true and they're collecting data on that, then we know that all of our assumptions and things that went into our design are in pretty good shape. And if they're not, then we should make adjustments and try to make corrections to improve our designs over time and make this a little more accurate. So as I wrap up here, I've got a few things to remember: that the pond inspections and maintenance is required. And I think it's really important to have a plan when we start our assessment. Visual inspections are a very economical place to start for our assessments. Where we can, we should design for maintenance, and we should pass that information back to the maintenance workers, the maintenance providers, through that plan so that they understand what should be a successful thing that they're looking at, and be able to keep the records on if it's not successful, that we can respond to that and come up with better designs moving forward. And with that, I'm going to turn things over to Purnima to talk a little bit more about other assessment and more detailed techniques. Thank you.
Thank you, John. Hello, everyone. I'm Purnima Trajan. I'm a researcher at the St. Anthony Falls Lab at the U of M. I'm going to start not exactly sort of follow John, but present a lot of the information that we have learned over the years with our many projects on ponds. Like Ben pointed out, 10 plus years of research. And it's not going to focus on monitoring with ISCOs. It's going to primarily give recommendations based off of what we have done for methods for monitoring, sampling, data collection at ponds, primarily focused on trying to determine if ponds are working for water quality tied to phosphorus. So a lot of the information I present will probably be a refresher of information that Ben Janke presented in the morning, and then we will go a little deeper into methods. So I'm hoping from this project, from this presentation, what you would learn, take away, would be these things that I would like to address, which is what are the key indicators of water quality functioning in ponds, and try to understand what we should monitor, why we should monitor, and how it can be done. And also trying to give some recommendations on some simpler diagnostic and screening type of tools that we have developed, worked on over the years that can assess these indicators of functionality in ponds. And in the end, hopefully we can take some of these guidelines and make it part of routine pond inspection so that everything together can be used for future monitoring and management of ponds. So here are some colorful pictures. Many of you may have seen it, which seem to be the theme whenever we talk about ponds. They look green, which means they have poor water quality. The key parameters which we focus on is high phosphorus concentration in the water column, low DO, and high internal loading, which is the release of phosphorus that is staying in the sediment back into the water column. So you can see that the pond is green either because of algae, high phosphorus, you have filamentous algae, maybe dead fish from low DO conditions, and also excessive growth of floating vegetation. So with all the projects that we have done, and trying to, and you saw the schematic earlier in Ben Janke's presentation, there are things that are within the pond, around the pond, and further away from the pond, which all together seem to impact whether the pond has these water quality functioning, primarily tied to total phosphorus, dissolved oxygen, and internal loading. So some of the things that we have come up with, or we call them as risk indicators, that is risk of having poor water quality. They are tied to the pond itself, like sizing and origin, their history, what's around the ponds, but also going a little deeper into taking some type of measurements to quantify some of the things in the pond, like sediment characterization or pond DO and things like that. And all of these have different effects on phosphorus cycling, mixing of the ponds and the DO, and also sheltering around the ponds. So I'm going to quickly summarize what Ben Janke showed earlier this morning. Very simple, high-level story that stratified and densely covered ponds with floating vegetation and ponds that have sheltering generally tend to have low dissolved oxygen above the bottom sediment. It is very obvious from all the trends we have seen in the many ponds we have taken measurements at, that if you have thick, dense vegetation of floating plants that cover the entire surface of the pond, there's a high chance that you have low DO. If you have more sheltering, then there is low DO, and things like that. And if you have sediment that has rich in organic matter and phosphorus and has high flux, then there are good chances that the water quality in the pond itself is poor because you have high internal loading along with anoxia in the pond. So put together, this makes a nice story. So how we know that from all the analyses that we have done. So this is just a list. This was our initial list. There are some new additions to this list, but they are mainly landscape and pond features that are affecting the key water quality variables. The way these have been arranged is by the type of data. So the first is basic site data, or less complex, which is information that you may have readily available, like if you have site plans, or maybe you can do some type of aerial imagery analysis, or you can do some site visits, or use the power of geospatial data analysis and get all of these parameters. And then we go a little further with more complex or intensive data, which can be obtained if you do some type of sampling or monitoring at the ponds, like anoxic factor, canopy coverage, wind reduction, how often does the pond mix, and all types of sediment characterization. So I present this in the beginning because most of the work that we have done have tried to be focused on these variables or indicators and trying to get at how you can quantify these. All right, so how to identify problem ponds. I already told you no ISCOs. So the first one is going to be field sampling and survey. This involves going out to the ponds, typically in the growing season from May to October when the ponds are really productive. And the information here is probably something that you already do, not only in ponds, but maybe in lakes, because it closely follows what is typically done for lake monitoring. For ponds, but just based on all the key indicators that we have looked at, the important things to take measurements of would be dissolved oxygen, temperature, and conductivity from the surface to the bottom of the pond as a profile. This data can help you determine what the depth of anoxia is, the mixing depth is, and there was somebody who talked about salt impacting stratification. So conductivity can give you that information, because in many ponds we have seen ponds start off stratified even early in summer, and the salt layer stays into like September until it completely washes off. So if you have a site where you think it might be impacted by salt input, that's something that you should be measuring. And also water samples, they give you the phosphorus concentration in the water column, both at the surface and bottom. Both are important because surface is where the plants like duckweed is, and bottom is where you have the sediment. So depending on DO conditions in the pond, you will have different concentration in the surface and the bottom of the pond. And how much of it is exported of the pond really depends on whether the pond is mixing or not. Once again, free floating plant cover. So far what we have done is visual assessment, which is like percentage of the pond that is covered by duckweed, 10%, 20%, 100%. Also, we have done biomass measurements that are most useful only when we are trying to do a phosphorus budget, but most often it is helpful to even just note whether you have duckweed and how much coverage you have. The next is the continuous field monitoring, which is high frequency data that you can get using low cost sensors. So if you do not want to visit the ponds, monthly or a few times, maybe you can invest in data loggers and sensors that can be installed in the pond and take measurements. Like temperature, they're pretty inexpensive. DO can get expensive, and also depending on where you install it and you may need more than one to actually determine the depth of anoxia, and other things like wind speed and water level that you can measure to get at both like mixing frequency, sheltering impacts, and also determine the water budget. The third is sediment coring, because that's where all the phosphorus is coming from. Typically, this is going to be a one-time sampling, I'm going to say. And either you collect cores, intact cores, with which you can do phosphorus flux studies, or you could do bulk sediment, which is sometimes easier to collect. It may not give you the same information, but you can get information like organic matter content and composition that you can get tested in any certified lab. For some of these other parameters, you may have to find a specialized facility like SAFO to do the work. So the reason you would do this would be to estimate the internal load, like how much phosphorus the pond is contributing to the entire phosphorus budget. It's helpful to have this number rather than try and model it or find it by difference like the bathtub does. So this can be done either in summertime or wintertime. It's possible to get cores anytime and really get at this information. So all of the information I presented so far requires some work, site visits, investing in sensors, doing some work, multiple visits to the site to really get all that information. But there are other ways to maybe diagnose and screen ponds before you start investing in actual monitoring. I know I'm kind of going backwards, but the goal of this type of work would be to do like a rapid assessment of a large number of sites. I know like some cities have hundreds of ponds, and how do you pick your sites? Do you want to visit hundreds of ponds? So we have some recommendations on how you could get started before you do that. So either you can use like basic site data, for examples that I presented before, that would be minimal site visits, maybe to ground truth. For example, I'll be showing in some slides about duckweed estimation, which might require some visits to the site, or maybe it doesn't require. You have all the information on hand. And also, it can be immensely supported by monitoring and sampling data, like minimal effort that can help do further assessment. So the primary outcome of this type of work would be to prioritize ponds for future monitoring or maintenance. It can be really helpful when you have identified your problem ponds and can channelize your resources to maybe focus on certain sites. So the first one is a diagnosis type of, is a pond classification scheme. This is new. We just came up with this system. And then we also have the pond assessment tool. Some of you in the room already know about it and have used it and tried it for your project. And I know some people who have done it. So I'm going to be talking about those two. So this is a pond classification system and not the pond classification system. I want to make that very clear, because this came out of a recent project, LRRB funded project, where we used CART analysis. Ben did all the analysis, did the CART analysis on about 68 ponds, both our data set and external data set, and came up with this very simple way to maybe put your ponds in different groups. So I have 5 groups of ponds from your left to the right. Group 1 has the lowest phosphorus to group 5, which has the highest phosphorus. So you start obviously, we have told this many times, duckweed is emerging as a really important indicator, either driver of low DO or a symptom of poor water quality. But that's where you start with duckweed, whether your pond has duckweed cover, whether it is at a certain break point, that's I think 19%, and you go down the chart and see where your pond falls. So this is for many ponds that this would just get you started, and it will give you like an average condition in the pond. Once again, we have more work to be done for this type of classification system, because there are many parameters that did not get included in this analysis, and it's definitely an ongoing work and can be improved. The next is the screening and estimation. If you want to go the next step, so the classification system is a pre-screening. So next is the screening, which is part of the pond assessment tool that we have worked on for the past few years, initially as part of a LRRB MnDOT funded project, and then with further support from MSRC, we were able to further enhance and validate all the models in the tool. So the screening tool is really presenting a risk of whether it has a high surface water phosphorus concentration. Once again, it only relies on basic site data like duckweed cover, emergent vegetation, construction year, or year it was developed, the surrounding area was developed, tree canopy, watershed land use, hydric soils, and historic wetland, whether or not it's historic. So a lot of the information can be obtained from like some type of GIS analysis. For duckweed cover specifically, you can use Google Earth imagery. I'll talk a little more about that in a minute. But all you're doing is trying to do this analysis and do a checkbox of whether it is low, medium, or high, and it gives you a score. So if you have 20 ponds that you want to screen, maybe this is a way to do it, and then you can rank your ponds based on the score that you get. I just wanted to touch on this because we talk about duckweed so much, and it is possible to estimate duckweed cover by just using Google Earth imagery. Here I present some examples, and I encourage you to look at this more recent report from Jacques Finlay, where we have a whole appendix with screenshots, step-by-step instructions on how you should do it. Scenarios where it is very clear what it is. It is duckweed, or maybe it is duckweed plus algae, or that very blurry image, you have no idea what it is. So that's a situation where you have to visit the pond to find out what's in it. So there's definitely resources out there to help you through this process. The other tools that the pond assessment tool has is estimation. Like, sure, you have screened the ponds, and if you want to go the next step and maybe estimate how much phosphorus is in the pond, then we have a set of, these are basically regression models that we put together. They all have the input data from the list that I showed before. And you will see that the models use both basic data and intensive data. The intensive comes from the type of monitoring or sampling that I talked about before, using a Hawk probe and taking profiles, taking some DO measurements, taking some sediment sample, and doing some analysis so that you can get some of the information, and also maybe pond bathymetry. So those are the types of information you would need for those models. So if you run the models, like, you have many options. So this screenshot shows you about 6 options, and the spreadsheet has a way to sort of put them all together, and we found that an ensemble mean gives you a better estimate, and every model has a standard error term, so you can pick your model based on what type of inputs you have. So you can see where your pond falls in the range of data that we have collected so far. And assess your risk. So same thing for sediment phosphate release. This does involve taking a sediment sample. Unfortunately, don't want to rely just on duckweed cover and estimate. It can be done, but we did not include that as a model. So that is some measurement that is required. But the very first model, that's something that any lab can do. Organic matter and TP, pretty inexpensive to do by any lab. So same thing, you would get an output like this to see where your pond falls in the range of data that we have. So if it's high phosphorus release and your pond is also anoxic, because the one that I did not show is the tool 2, which can estimate the oxygen status in your pond. It can give you the input that goes into some of these models. So if your pond is experiencing anoxia for a long time during summer with a high P release rate, that means you're going to have significant internal loading in the pond. We have presented this tool to practitioners before. I know some of you know that. So one of the things that we were asked is, okay, this is a lot of information, and we need to know how much effort is going to go. How can we plan all of this? So this is a workflow that Ben and I put together for that project, where if your goal is to screen the pond, so this is basically summarizing what I just talked about. Like, where do you start and how do you go through the steps? So if it is screening, what is your goal and what do you do step by step? So if you want to do the next step, which is estimation, then what do you need? What are the which is like, what is the input data that you need to gather? And then what's the field information you need and which tool you can use, what output it gives, and how to put all of that together. So once you have done both, then you have an idea of, okay, whether or not your pond is at a risk of having poor water quality. So one of the things I wanted to include is for people on the ground who are doing the inspection. So maybe there are things that can help people who are like the engineers who are in the office, and maybe they can use the data that you collect. So maybe add some information to the routine pond inspection, so that it can be an indicator of whether the pond is experiencing low DO, high phosphorus condition. For example, that picture on top is a wetland in Shorewood. So if you go stand by the shore, you can hear pop sound. That's from gas bubbles that are being released from the pond. And that's a close-up picture of the bubbles mixed with the duckweed. I love that photo. And I showed in all my presentations. So they can actually note down some of these visual clues in like your routine pond inspection, maybe like dense cover of duckweed and woofia and lots of bubbles, and there's an odor or mucky sediment that they can see, and evidence of wind sheltering. Like, are there like overgrown trees, or is it like a high bank around the ponds? And even if it's a pretty windy day, really there is no movement in the water, that can be a sign. And with this, I know we talked about duckweed a lot, and Jacques is going to be talking about other vegetation in ponds that can be important, and also for duckweed is like on the worst side of poor water quality, but there can be other indications of better water quality based on the main vegetation groups. So I'm also again going to refer to that same report where there is a rapid assessment method for vegetation. So maybe there is something there that can also be extracted and incorporated into like pond inspection to expand beyond duckweed. So key takeaways. So hopefully everyone is convinced that as ponds age, they can become less effective in retaining phosphorus and have poor water quality. Inspection and monitoring beyond the structural inspections and that go on. Monitoring and visual inspection can include some of these key indicators of pond functionality that I talked about. And there are tools to diagnose, screen, and sample ponds that can help prioritize or identify at-risk ponds and maybe guide their future management. So I would like to acknowledge our project team and also the other many students